Well, thanks all of you for coming to my little workshop here on teaching statistics beyond the graphing calculator. I'm going to start with probably the coolest thing about Google Sheets, and that is the ability to share a data set and share a link. So if you're logged into Google, then to navigate your way over to Google Sheets, you can click this little hash of dots from, the icon next to your picture, and then click Google Sheets. That'll get you to Google Sheets. But what I want to do is I want to share a link with you. And there's a couple ways you can share links. It depends on what you want people to be able to do once they have your link. Let me click share, and then you can give general access, or you can give editor access. Now, I never give editor access because I don't want students messing with my data. So I come down to here. There's a couple options. There's restricted, anyone with a link. And I just choose that one. Anyone with a link, copy the link. And let me put that in the chat for all that are here. And this link is going to be able to give you like everything that you need from my presentation. So Gerald, when you get around to making a Google account, you can click on this link and copy all the data that I have here and all the other things I've got going to your own Google Drive. So if you want to open up that link, that'd be great. I see a few of you are doing that just now. Let's see. 4, okay. So maybe Julie's already got off 5, 6. That's looking a little bit better. So once you have this link, then you can see what I've got going on this page. But the fun thing is that you can store it for yourself. So if you go to the file menu here, slide down to make a copy. This puts a copy of that data on your Google Drive. So now you can edit it, you can look back at it, you can make changes, whatever you want, but it's your copy now. So what I like is that I could send this link out on like a Thursday night, and then keep on working on it until my presentation Friday morning. And when you open up that link, all the changes will be there. So if you had like a static file, like an Excel file, and you work on it, you send it out to your students, and then you're like, oh, wait, I need to make a change. Well, then you got to send out a new file. This is a lot more convenient, and it's a very seamless way to share data and presentations with your students. So that's probably one of the coolest things about Google Sheets here, but there's a lot more. So let me start with some basic commands for Google Sheets. It does all your basic statistics, and I use it for some of the basic statistics and some work with probabilities. Let's start with the basic commands. Kind of like Excel, everything's in terms of a command starts with an equal sign. And I think, let me go back here to Google Sheet commands. I've got all the names and examples of how to do these calculations here. So we'll look at some t-distribution stuff, some binomial distribution, some normal distribution. It works pretty nice, actually very nice. If you click this little All Sheets button, we can practice some of this stuff with basic statistics. So that should bring you to this sheet that I literally used in class on Wednesday. Now let me pause for a second and make sure that everyone's able to keep up with where I'm at. Are you on this basic commands sheet from my Google Sheet? Okay, I got a couple nods. All right. Does anyone need another minute? Ken, doing okay? All right.
Doing fine, yeah.
All right, thank you. So let me scroll down here. I've already got the sum command typed in, and I'm going to show you a couple different ways that you can tell Google where you want to find the sum. So I'm just going to erase that, start all over afresh, click sum, And when you type in sum or you type in any command, sometimes it'll anticipate what you want and say, okay, you know, fill in some things for you. If you press the enter key, it'll fill in the rest. Now I want the sum of these cells starting in B2 all the way down to B12. So let me just type that in, B2 colon B12. And then I feel compelled to put that right parenthesis, even though I know that Google Sheets will understand if I didn't. What's cool is that it shows you the area that you're trying to sum up, which I like. So if that looks good, then just press the enter key. Now that's okay if you know exactly where you're going to start and where you're going to end, but sometimes it's not terribly convenient. So another way that you can do this is if you hit equals, and then this time I'm going to practice a different command. It's count. That'll tell you how much data you have. And instead of actually typing in the cells that I want, I'm going to click and drag and highlight the cells that I want, and then press enter. So those two are generally pretty friendly. And for the most part, I suggest that students use those. If you want to get fancy, or if you want to set something up to be helpful for your students, you can. One of the things you can do for your students, if you want to, is you can name a data range. So if you click data and then go down to named ranges, I've already got this one set up, but I'll just edit it and show you. You can name this anything you want. Usually you want to keep it short so it's easy to type. Maybe also keep it lowercase. And so EXB is going to be synonymous in Google Sheets with B2 to B12. So that's cool. That means that anytime I want to reference this data range, I don't have to click and drag or type that in. All I need to do is type in equals, and then confoundingly, if you want the mean, you have to type in average. So average of EXB, and bam, there you go. There's also some other really handy commands too. You've got the median and the harmonic mean, the geometric mean. So equals median, and then let's do EXB again. So some nice basic commands to get you some good summary statistics. Obviously you can do standard deviation and things like that as well. But for the most part, what I wanted to see is different ways you can name or different ways you can reference your data set. So we okay with some of these basic commands. One thing that's handy, because this is Google, if you weren't sure about something, you're like, well, how do I find standard deviation? This is Google. You can just Google it. You can say, all right, standard deviation, Google Sheets. In fact, it even anticipates me. Should give you a nice link, what you want to do. Here we go, support.google.com. And so it's going to give you a much fuller explanation than perhaps I've given you for some of these commands. So it's pretty easy. When you know you want to use something, you can just go Google it.
Tell all of my students that.
This is true. Let's move our way over to a different part of this sheet here. So the next thing I want to look at is some inflation data. So if you click this all sheets thing, you can scroll down to inflation. And the nice thing about Google Sheets is that you can be really dynamic. I mean, certainly you can envision yourself being in class and some topic comes up and you're like, oh, well, let's look at this. And yeah, even though I didn't do it right now this morning, it took me about 30 seconds to copy, cut, and paste all this inflation data into this Google Sheet. So that's kind of nice. One problem that you might notice, though, is that when I start scrolling, I lose, the titles at the top of this. And that's kind of frustrating. So there's a cool thing that you can do to keep those things locked in there. And that starts by taking your cursor and putting it right underneath this little box that says C121, or at least says C121 for me. But it's the box at the top next to the A's and at the top of your column. If you want to lock some of these in place, so you want to click and drag it down to the third line, like there. And now when I scroll, that top part won't scroll. So that's really convenient. I kind of like that because I like being able to see what are the headings for these columns. In a similar way, if you want to lock, say, the first column, if you're like, oh, I want to be able to see what year it is when I'm scrolling, you can click and drag over here as well. It's just a nice little thing for the readability and the visibility of your students or you to be able to lock these things in place. So that's kind of another nice trick that I like about Google Sheets. Now, as I go through this, if you have any questions about something, please chime up. I mean, that's what we're here for, is to help you learn and understand some of this stuff. So I think I remember a Benjamin Franklin quote. He goes, and it goes something like this: beer is evidence that God loves us and wants us to be happy. And I think you can say the same thing about statisticians and M&Ms. So let's do a nice little experiment with M&Ms. And let me cut this open here for us. Oh, I lost one. I'll get that in a second. And what I'm going to do here is I'm going to take and put this underneath the magic sorting hat from Harry Potter. And then let's take another look at it. And oh, cool. Wow, that's pretty nice. Let's see. Let's do some counting. We've got 7 red, 3 orange, 3 yellow, 18 green, 6 blue, and 20 brown. Is that unusual? Well, the one part that's not unusual is that when you open up a bag of M&Ms, you usually get about 57 in the 1.69 ounce bag of M&Ms here. So that part works out pretty good. But how about the color distribution? Kind of a little background for you in terms of the color distribution. There's 2 plants that produce M&Ms. One of them is in Hackettstown, New Jersey. And the one that produces our M&Ms, the ones that we get here in Michigan, is in Cleveland, Tennessee. Yeah, that's right, Cleveland, Tennessee. I never knew there was a Cleveland, Tennessee until I started looking into the M&Ms. In any case, let's go over to the M&Ms portion of our data set. So you can click up here or scroll along the bottom. And let's enter in the data for our M&Ms into this sheet. Now, I want a little bit more real estate here for myself, so I'm going to click this up arrow, try and get rid of a few things. And let me just check back with the numbers that I had here. It was 7 for red, 3 for orange, 3 for yellow. And as I'm typing this in, you might notice that it's updating the sum here at the bottom. And it's also starting to update the expected values. I'll get to that in just a second. So green was 18, blue was 6, and 20. There we go. There's your even 57 M&Ms. Now, what's fun is that we're doing this all live, but yet I've got these formulas filled in so that if I treat each one of these colors as a binomial random variable, then the expected value is just going to be n times p. So that's going to be this number here, 57, times this probability. Now, I didn't type in the 57. That number was just generated by the sum of this column. You can see here that I've got highlighted that I've got that total there in the cell D10. Well, over here, I'm going to tell the spreadsheet to take D10 and multiply it by this number here. If you copy, cut, and paste all the way down with just D10 as is, it's going to also kind of change the cell it's referencing. So if I copy this, say, down to here, instead of referencing this cell, it's now referencing the cell below that. So really what I want to do is I want to lock this cell. I'm like, you know what? You can update the B column, that cell, but if I wanted to lock this one in place and say, just use that number, I can do that. So the way you do that is you put a $sign before the column, so a $sign before the D, and then another $sign to lock the cell. That way, that number is going to stay fixed throughout whatever calculation you're doing. There we go. So that's kind of a handy trick. You can look through now. You can do some other stuff with standard deviation. You say, all right, plus and minus 2 times standard deviation is that value of the observed in that interval of 2 standard deviations. And we saw that this is an unusual bag of M&Ms in as much I had a couple colors that gave me values outside of what would be expected. I'll be honest, I've done this experiment dozens of times for my students, and it's rare that I get a bag that has even one observation outside the norm, let alone 2. So you guys are my lucky crowd here. Okay, marching along. How are we doing? Let me pause for a second and see if you guys have any questions for me or curious about something. I am going to talk about some probabilities, binomial probabilities, normal probabilities, t-distribution, that kind of stuff. But let me pause for a second. Just maybe give me a thumbs up. Doing okay? Thumbs up? All right. All right. Let's keep going with Keno. And so I'll go to my Keno chart. Keno's a game that's played by the Michigan Lottery. And there's 80 numbers. I think the lottery chooses out 20. And you got to decide how many of those 20 you want to try and match with your guess. So you can try and match 4 numbers, and they'll pay you out according to this probability distribution. Now, the probability distribution is stuff that I've done, but you can have calculate, for instance, expected values. That's just x times p of x. And again, you can set some of this stuff up. Now, I did make a little error here that I want to fix. The 10 spot. So these are all your expected values, and I've got them on a chart that goes along with this. And you can see that this one looks really out of sorts compared to the rest of these. So what's going wrong here? Well, let's go down and take a look at what I've got with our 10 spot. And let me just kind of scroll down slowly. And oh, it seems as though I forgot to copy and drag when I did this calculation. So all I've got is the first entry here. So let me just copy and drag here. Drag that formula all the way down. And now it updated the probability or the expected value. Now this is for a $1 bet, but it also updated it in a couple other places. If we go back to the top, it updated the value here, and it also updated the value on the chart. I don't know if Excel does this or not, But I think that's really cool that something can update in multiple sheets just based on changing it in one place. I'm going to give you another, one last remark here. I find it really interesting that the expected value for these games varies drastically. I mean, the 4 spot, you expect to lose about 9 cents for every dollar you bet. And the 8 spot and the 5 spot look like really bad bets. It's just surprising to me that there's such variability in the expected rate of return here. Okay. Let me give you another link here. And again, I'm going to hit the share button. And anyone with a link can view. That's the choice that you want. You don't want to make them an editor unless you're really, really comfortable with that. So I'll put that in the chat. Now this data set is not only up to date, but very complete. It's the average monthly temperature in all 83 counties of Michigan going back to 1895. So it's a pretty cool data set. It took a fair amount of work to whip this one into shape and to get it here. So it's yours now. Do with it as you will. And, you know, it's just got a lot to offer. Now, there's a lot of counties to look at and a lot of data. You might get a little bit overwhelmed. So you might want to focus on one county. So it's like, well, gosh, I don't know. Let's just focus on, say, Keweenaw. If you go up to county, you can filter by condition or filter by values. So I'm going to do filter by values and start typing in Keweenaw. And then click that. Actually, it is already clicked, so I don't want to click it again. And then I believe I got to hit the OK button. Now, it might take a second or so because this is a big data set. I'm just holding my breath because this is a live demonstration. It does work. Even if I kind of make a mistake here, it will work. And in fact, part of the data that I've given you here is I just pulled out Oakland County's data. And then I went a little bit further and I boiled it down for you. Let's see. Yeah, it's this one. These are average temperatures by decade in the various counties. So if you wanted that, you can get it. Let me go back to our full data set. All right. Why isn't that working? Keweenaw. I'm going to give this one more chance. You can filter these things, even if there's a problem someplace between my standing mat and the keyboard. You can filter these things. This should be kind of solid when it happens. So, clear Keweenaw. All right. My dog joined me and he wants to play. So I'm hoping this one will work. That one should work. Now give it a second. There we go. So I had to clear that first. And now you've got just one county. So that's pretty handy depending on what you want to do. If you want to filter out some stuff. I do have a couple more things to take care of with respect to this, with respect to Google Sheets, and then we'll move on to a couple other things that you can use for your statistics class. Let's see, let me go back to, all right. Guess I got to pause here for a second. So we'll go back over to the inflation data set, and I'm going to scroll to the bottom just to highlight a couple other commands and things you can do in terms of data sets. So I've got some basic data here, but a couple other things that might be of interest would be finding a percentile. So to find a percentile, you just give it your data range, and then you type in what percentile you want as a decimal. So if I wanted the 5th percentile, this should be 0.05. So that's the 5th percentile. You can also do this in the other direction. If you want to find how something ranks in terms of a percentile, then you can use the percentile rank command. And of course, if I wanted to fill this out for the rest of my data, I'll just highlight that whole thing and click and drag that all the way over to here. And now I've got all the numbers for all my data set. So kind of nice. Probabilities are one of the cool things that motivated me to use Google Sheets. So I'm going to go over to the probability sheet part of this right now. And we've got binomial probabilities here. The format for that command is you type in the number. Now in this case, in order to set up the formula, I've referenced this cell. So instead of typing in the number 0, I said, oh, reference this. That way, when you copy, click, and drag, it'll update this value all the way down the column, and you can get the PDF for the binomial distribution in seconds. So kind of nice. Then you can calculate expected values, etc. But really, what I want you to see here is that this is kind of fun because you can use different ways to calculate these probabilities. For instance, say if I wanted the probability that X is less than 4, you could do it by the direct approach, which would be something like this. Just sum up those values. So I've got that here. Or if I wanted the probability that X was greater than 4, again, you've got the direct approach, or you can use the complementation rule. And there's one last rule that you can use, or one last thing you can do, and that's use a slightly different command. When you're calculating these probabilities, if you want the binomial PDF, you're going to use false here. So the format of the command is X, and then N, and then P, and then false. False is going to give you the PDF. If I did true, I'm going to get the CDF, so the cumulative density function. Now, it's a distinction that's sometimes a little tough for students to do. So sometimes I don't mention this that much, but you can use the CDF, and then you can use the complementation rule using the CDF. So there's 3 different ways you can demonstrate for them to calculate this probability. And it's just all based on what's convenient. What I like is that they're not going to make a mistake by fat fingering a button on their calculator. It's just let the sheets do it. And it's really cut down on those kind of errors. And if they make an error, it's for something else. It's a misunderstanding somehow. Let's see, updated. Now, let's see. There is one more thing that I want to mention here. You can do other probabilities as well on Google Sheets. So for that, I'm going to go back to Google Sheet commands. And we'll look at normal distribution. So the format for the CDF in a normal distribution is kind of like that of the binomial distribution. If you put in true here at this end parameter, true is going to give you the CDF, false is going to give you the PDF. I can't think of a single reason why in a basic stats class you'd be using the PDF. We're always going to be using the CDF. So something to be aware of there. You can do the inverse distribution as well. So if you want to basically do this formula here, mu equals sigma times z sub alpha, you can do that as well. You just got to make sure you type in your percentage as a decimal. Don't put it in as 95, put it in as 0.95. You can change the mean, you change the standard deviation. It's nice. What I like about it again is that People aren't going to make calculator mistakes, those kind of things. It's a lot easier for the students. Likewise, you can do t-distribution, and then here's some examples for you for the binomial distribution as well. So it has a lot of possibilities. Personally, I'm teaching stat now, and when I teach stats, I use Google Sheets up through about the normal distribution. So chapter 6 in Triola, if you're using Triola. But that's about where I start merging into some other technologies, including StatDisk. Now, as far as teaching or as far as testing is concerned, there's two options that I would suggest to you about how you're going to test if you're letting people use all this technology. The first one is that you could just write a test in which you give people summary statistics, figures, graphs, charts, whatever it is, and then let them make their own conclusions based on that information. So they don't necessarily have to reference Google Sheets or anything like that. They can just look on the test and see what they've got. The other option that, and I've used both of these, the other option that I have is that I'll have students turn their desk around so that they're facing the wall and their computer screen is facing me. And I tell them, you can have 2 tabs open, one for StatDisk, one for Google Sheets, and that's it. And I'll tell you what, when somebody's looking over your shoulder, they don't mess around. I've never had a single problem with people cheating or having extra tabs open on the test. It just doesn't happen. I suppose that if it's impossible for you to get behind or have people turn their desk, then you could just, move your desk maybe, or move a chair to the back of the classroom. But it's worked really well. I've not had any problems testing like this in my stats class, and I've been doing this for several years.
So do you require all students to have a laptop?
They all do, although this is the first semester I have a student that doesn't have a laptop. He's got a desktop. And I asked him to check around and see if he could borrow one on test days. And, we'll see what happens. If he can't, I might see if I can scavenge one around my house and just bring it in. But this is the first time ever, and like I said, I've been doing this for years, that somebody hasn't had a laptop available to them. So we'll see. So
Jeff,
yes.
Orchard Ridge Library has like 4 laptops to check out for the class time. I use laptops in the class, in the core requisite class, and
really?
they've been checking them out for the class time.
I'll have to see if the Southeast
Check
campus.
Check if our local library has that too.
Yeah, I appreciate the suggestion. Thank you.
Sure.
Thank you. Now,
so Jeff, are you able to give them bigger data sets if they're using like that kind of technology on the exam then?
oh yeah.
Yeah.
I mean, because the numbers crunch really fast.
Right, because they're not typing those numbers in, correct?
Exactly. And,
Okay.
Going back to the days when we did this on a graphing calculator, you're gonna make errors. Somebody's gonna make an error inputting that stuff. And
I used to run around with a cord. I used to run around with the cord and give them to them on the calculator.
That's ambitious.
Yeah.
I've done stuff like that, and what I did is I taught some of my students to do it as well. That way you cut down the time, but
Yeah.
it's just not fun, and it's much more streamlined to be able to give them a data set like this
Right.
to work on directly. So that's all I have to say about Google Sheets. A lot of the rest of this is going to wrap up pretty quick. I did this last night with Linda. I did the first 45 or so minutes with Linda on Google Sheets, and then the rest of it wrapped up pretty quickly in like 15 minutes. If you want to leave, no worries, but I'm going to go over StatDisk next, and then some brief mentions about Desmos. Desmos does some really cool things with statistics, and then just a little flash look at something in CoDap, just like 2 minutes worth. So to move on to StatDisk, I know that a couple of you in your campuses are using Triola. And if you're using Triola, StatDisk is wonderful for Triola's book. So let me again put a little link in the chat. It's just statdisk.com, but there it is. And I'm going to go back to this. When you get there, I'm thinking that your data sets should be clear. Not sure, but if it's not clear, you can hit the clear button. Again, one of the nice things about doing this stuff on the computer is that you can easily pull up data sets. And forever and a day, I was always frustrated by the fact that Triola had some wonderful data sets, but it just wasn't easy to put them on students' computers. Now, in addition to being an online resource that you can use for free, and it's system compatible with everything, you can get the data sets just by clicking. So you click underneath here, data sets. We'll go with the 14th edition. And there you go. What do you want? I mean, there's even more data sets than we're seeing here because this goes down and down and down. There's just a ton of data sets. We'll keep it easy and click body data. And wow, there's all your data exact from the publisher. It'll match the stuff that's in the book. Makes it really easy. Of course, you can copy, cut, and paste data into this as well. It doesn't necessarily have to be the data from the author. But the reason I never really bother with charts and things like that on Excel is because it is so easy to get stuff like this out of Triola. If you click data, one more time, click data and go down to explore data and descriptive statistics, it'll give you pretty much every descriptive statistic that you want. Pick your favorite column. We'll pick weight, or you can pick whatever you want. And you click that, and wow, there's everything. The mean, the median, the mid-range, root mean square. I'm finding it amusing that he puts that in there. You've got a nice distribution here, gives you a nice histogram. It even gives you a confidence interval for the mean and standard deviation. It gives you a box plot and a QQ plot. And if you want any of these, you can download them as PDFs by clicking on the camera icon. So if you're making a presentation or you wanted a test and you wanted these, good files, hey, you can do those. So really, really nice there. But you can do a lot more than just basic statistics with StatDisk. If you click analysis, what do you want? You want a confidence interval? You want hypothesis testing, correlation, regression, and the cool stuff, which I've actually written programs for, and I'm very happy that it's here, is some of your non-parametric stuff. I mean, back when we added an extra credit hour to this course back in the 1990s, part of it was to expand the list of topics, and the other part was for technology. Well, we're meeting this technology by doing stuff like Google Sheets and things like that, but this makes it so easy to do a Kruskal-Wallis test or Wilcoxon sign rank test. It's just really, really nice. Now, if you're ambitious and you want to go a little bit beyond the course, you can do some resampling and some bootstrapping as well. I've flirted with this. I've shown students what it is, but I haven't really done much more than that. But it's nice that it's available if you want it. And it's just so easy to use this stuff. So that's StatDisk. I highly recommend it if you're using, especially if you're using Triola, even if you're not using Triola. My son took this class at OCC, and then later in his degree for economics, he went back and used StatDisk just because it was so easy and convenient. It's a really nice platform. Comments or thoughts on StatDisk? All right, those of you who know me know that I love Desmos. I really love Desmos. So what I did is I took one of the columns of data from Triola and I pasted it into this link right here. And I think I've got those links here for you. If you click back to the basic link that I shared with you at the beginning of this and click links, there you go. You've got basic stats, visual basic stats, normal and binomial distribution, and then below that, there's a t-distribution. So the demonstrations I'm going to do next, all those links are here for you. So if you just want to sit back and watch, or if you want to follow along, it's up to you. But this has surprised me, and I haven't fully come to grips with how much of this I want to use in a stat class, but there's a couple things I will use, and I'll just show you what I've got, and you can pick and choose what you want. So I pasted some data from a Triola set into this disk, or into this as a list. It's A, and then you can do the mean of A, standard deviation of A. You can do pretty much whatever you want, min, max. There's a lot of possibilities here, more than I'm going to touch on. And it'll even do a histogram for you. And you can change a lot of the settings. So let's do histogram. And I've already got the window pretty much set up like I want it. It has this magnifying glass here that'll do kind of a zoom fit, but I'm not really happy with it because watch what happens when I do zoom fit here. I don't know. I think that I like my window better than their window. So here's a little trick for you if you're not familiar with it. If you want to zoom in, say on just one axis on particular, instead of necessarily going up here to the graph settings, what you can do is hit the shift key and hold this next to one axis and then scroll in or out, until you find whatever you want. And then I'll do that on the y-axis as well. So let me get over here to the y-axis. So I want to make that a little bit taller. There we go. I should have done the y-axis first. And there's a histogram. So nice. What if I wanted a box plot? Well, I can do a box plot as well. Now the box plot, initially its basic settings have it so that it's overlapping the histogram. Maybe want to change things. So the offset tells you where it's positioned. Right now it's at a height of 3. Now let me put it down at maybe -6. That way it's underneath the histogram. You want to make that histogram a little, or the box plot a little taller, change the height. Let's make that a 5 or a 7. So you can play with that as you wish. And those are just a couple of the basic summary statistics you can get from Desmos. But the fun stuff is what's coming here. The second link that I gave you for Desmos is something I use when I have students learn about standard deviation. So the nice thing about this data set is that it's kind of interactive. You can change the values here, and then you can dynamically see the effect on the change of the mean, the median, the mode. Well, not the mode. I got to reprogram this. I want to get rid of mid-range and put the median. But I can change all these different values. And in particular, what I ask my students when I give them this is, hey, tell me what makes the standard deviation bigger and what makes the standard deviation smaller. So rather than me telling them what the standard deviation does or is, I let them figure it out on themselves. And that goes in line with one of the objectives for our community of practice last semester. We did this building thinking classrooms in which, you're trying to get the students to think more and be passive learners less. And by giving them this and saying, all right, figure out what the standard deviation is, that's what I'm trying to do, is make them actually think through and say, oh, well, gee, if I dial all these down to about the same number, then that number for the standard deviation starts to get pretty low. Or if I spread them out a lot, then I can make it higher. So kind of fun, a nice visual thing that you can do for your students. And of course, Desmos, its strength, of course, is visual. So this is the binomial distribution. Again, it's the link that I gave you earlier. And that's kind of nice. You know, these dots here show you the probabilities of success. So this is for a binomial distribution with n is 200 and p is 0.5. But what if you wanted to find cumulative probabilities, not necessarily an individual one, or maybe I don't want to go looking through to figure out, all right, what's the probability that x equals 95 in this distribution? You can do cumulative probabilities. So let me click that, and it actually highlights the probabilities that you're going to add up. So this is from 90 to 100. The probability of getting something in this range is about 46%. Let me bump that up to maybe 105. And when I make this 105, two things are going to change: the picture to the right and the probability below. It's just fun for me to be able to show them what that distribution looks like. And of course, what does this distribution look like? This should remind you of another distribution that we use. The normal distribution, right? So if you compare this, this should be a normal distribution with a mean of 100 and a standard deviation of the square root of 50. So I can overlay that and say that, oh yeah, that's a pretty good approximation. Now, I don't know if many of you have been teaching this in your statistics class or not, but when I first started teaching and we had to do things with the graphing calculators and tables, we had to find probabilities, normal approximation to binomial probabilities. So if I just try to do a regular approximation, 90 to 100 underneath this curve, the probability doesn't match too well. And you can talk about, if you're really motivated, the fact that, oh, we need to do a continuity correction on either end. And when I do that continuity correction, because you're approximating something which is discrete by something which is continuous, you get a really good approximation. I mean, this is to within a 10,000th of each other. That's pretty impressive. Let me shut these off and go down to another demonstration, which is kind of fun. And that's this. We know that we can use the binomial or the normal approximation to a binomial distribution sometimes, but under what conditions? Remember under what conditions we can make that approximation? Well, it was something about n times p had to be greater than something. So what I've done here is got a binomial probability distribution with n is 100 and p is a slider variable. And you can look at the distribution, and I got to make this a little bit narrower. There we go. And right now, this doesn't look like a normal distribution, but that's with p is 0.01. If I drag this, then let me make this a little bit shorter. If I drag this, then I can see that for a good range of values, this is approximately a normal distribution. And it's only when I get to the end that, oh, that approximation breaks down. So you can really give students a good justification for why you'd want to do a normal approximation or when that approximation is going to be good. It does permutations and combinations. So if you have a student that doesn't have a calculator sometime, they can do it right there in Desmos. One last thing about one last demonstration about some of the things you can do here. And I know you can do statistical tests as well. I haven't gone down that far with Desmos. But of course, we use a t-distribution, and William Gossett Jr. realized that sometimes you need to use a t-distribution as opposed to a normal distribution. Of course, we tell our students that the normal distribution is in some sense the limit of the t-distribution as your degrees of freedom increases. So let's actually look at the normal distribution. There's your normal 0, 1 curve. Here's your t-distribution when degrees of freedom are 1. Well, what about when you have 2 degrees of freedom, or 3, or 4? And it gives, again, a nice visual for the students to see that, oh, as I increase the degrees of freedom, the difference between these 2 distributions is less and less and less. And if you want to, you can change this upper parameter to be like 30 or whatever you want. But I find that it makes it a little harder to scroll slowly when you've got a bigger value like that. That's why I had mine set at 19. So that's it for Desmos. Some fun visual things there. I've got about 2 minutes left. I'll show you some things about one last program called CoDap. And this is a link again here. Let's see, CoDap. When you open this one up, and let's see, can I just open that up here for us here? Copy. I'll paste over this one just so you understand where to go. No, it didn't. Did it not update? Okay. When you get to this website, you're going to want to open up a specific set of data, and it's the roller coaster data. All right, this is what I was looking for. Come on, come on, come on. We're going to want to look at the roller coaster data. That's assuming that, wait. It's still not liking this one. All right, I'm going to shut that page down, try open it again. Holding my breath here. Oh boy. No, I don't want that. Exit. Let me see if I can get it to open in a different browser. Let's see. What's Microsoft's browser? Edge?
Mm-hmm.
Let me open up, see if I can't open it up in Edge. Boy, it just, there we go. Is it working? It looks like it's still thinking, or still loading. Wow.
Yeah, you got a lot open, and that visualizer is a big memory suck too, especially when you're online.
Yeah. Exit page. Oh boy. All right, tell you what, I'm going to close out all of these and hopefully that'll let me get back. Yeah, let me get rid of visualizer as well.
Yeah.
And maybe this will work again. Let's see, Chrome. Ah, not again. Wow. Oh, whew. There we
Yeah,
go.
look, there we go.
Okay, so they got some really cool hurricane data here. I haven't played with that data set yet. So I'm going to open up the roller coasters data set. So let's open that up, and it'll give me 2 copies of the data, kind of 3, I guess. Here's a description of the data that I'm going to close out and move away a little bit. I'm just going to grab one of these. Each point here represents a point in my data set. And of course, right now they're unorganized, but you've got all this data that you can look at here. It tells you the park that it was, the coaster's at, the name of the coaster, top speed, max height, duration, length, type, etc. And it's just kind of fun. I think this would appeal to, some of our students need to be visual and active learners, because you can take, for instance, type and just drag it down to the x-axis, and bam, it's right there. If you want to compare that to design, well, I can put design on the y-axis. And it's just nice that you do these things dynamically. Now, let's see. What makes people thrilled about roller coasters, generally speaking, is the top speed. So it's not letting me do that. Let me try that again. All right, tell you what, we're going to get rid of you and then go to you. So let's keep on playing around. Top speed is kind of fun to look at. If I put it on the y-axis, I'll get basically a sideways histogram of the top speeds. And if you click on any one of these dots, you're like, oh, where's the top speed? Top thrill dragster in Cedar Point. Okay. But more like what we would like to do would be to figure out, well, what's predictive of the top speed? So that would be the max height. And you drag that over here, let it shuffle around, and there's a nice linear relationship. If you want to quantify that linear relationship, let's click the ruler and add in, for instance, a least squares line. Now you've got your least squares regression along with your R squared. So, wow. CoDap looks amazing. I played with it a little bit, but that's all I got for you here. So, comments or questions? All right. Let me stop the recording. Let's see here. There we go. Thanks for coming by.